Now let's talk about the 5 types of thermometers that are very important for us to know about. The first one is called the constant volume gas thermometer. Constant volume gas thermometer. Now the thermometric property for this thermometer is pressure. Because the volume is constant, the volume will not change. So what will change? Pressure. So pressure, the change in pressure will indicate a change in temperature. Similarly, the next thermometer is constant pressure gas thermometer. Now in this, the thermometric property that changes to indicate a change in temperature is not pressure but volume, because pressure is constant in this. So as your volume changes, it will indicate a change in temperature. The third kind of thermometer is an electrical resistance thermometer. Now this is one thermometer that we will be particularly interested in, and we'll talk about it in detail. So electrical resistance thermometer, in this the thermometric property that changes to indicate a change in temperature is the resistance. So the resistance, that is in ohms, it changes and it indicates a delta T. The next one is thermocouple, again an important one, and we'll discuss this also in detail. In thermocouple, the thermometric property for us would be the thermal EMF. The thermal EMF, or the electromotive force that is developed due to a temperature difference. Okay, now the last one is the mercury in glass thermometer. That is the common clinical thermometer that we use, and for this the thermometric property would be the length of the mercury column. So this is the 5 thermometers that we should know about. Now let's discuss the first very important kind of thermometer, and that is the third one in this particular column, that is the electrical resistance thermometer. Now very briefly let us discuss the electrical resistance thermometer. Now in this resistance thermometer, the change in resistance of a metal wire due to its change in temperature is the thermometric property. So let us say this is the wire, and this wire, let us say the resistances are, this is incorporated in a Wheatstone bridge. So this is a Wheatstone bridge. Alright, Wheatstone bridge. And this wire is usually made up of platinum. Alright, now this platinum resistance thermometer, that is the platinum is this is the material platinum, and this is the resistance that we are going to measure, and due to the temperature change the resistance will change and we can measure it with the help of this Wheatstone bridge. Now this has a very high degree of accuracy and sensitivity. So for this reason of having a very high accuracy and sensitivity, this kind of a thermometer is used as a calibration tool for other thermometers. Okay, and the value of the measurement of the resistance R is equal to R naught into 1 plus AT plus BT square. Now in this quadratic equation, the value R is to be found out. This is the value to be found out, and this is the value of the resistance of the platinum wire when it is surrounded by melting ice. Now melting ice would be at 0 degrees Celsius, so that is why it is having a 0 in its parenthesis, and these values of A and B, these are nothing but mere arbitrary constants. Okay, so this was a brief introduction about the electrical resistance thermometer. Now after this, let's discuss about thermocouple. Now let's discuss about thermocouple. Now thermocouple is a circuit. Now this is a circuit that you are looking at on this diagram. It is made up of joining two wires. So in this case we have wire A and wire B. these two wires are made up of dissimilar metals. So the metals are not of the same kind. And this is junction 1 and the other junction is, let us say, this is the other end of this junction and this is the other end of the other wire. Okay, now a very interesting phenomena takes place, that is the Seebeck effect in this. And due to this Seebeck effect, a net EMF is developed in the circuit, which depends upon the temperature differences between the hot junction, this is the hot junction, and these are the two cold junctions. So there is a temperature difference between this junction and these junctions. Due to this temperature difference, a net EMF is produced. Now this net EMF is the thermometric property of this circuit, and this EMF can be measured with the help of a microvoltmeter. So this is the connection which goes to the potentiometer, and we can measure this EMF, and the EMF then gives us the measure of the temperature. Okay, and how can we say that this is hot and this is cold? Is because this end of the wires is kept in ice water mixture, so automatically this becomes cold. Alright, now the choice of these two metals of the wires, it depends upon the temperature range that is being measured. Normally there are two kind of materials that we use. So the first pair is called, or is made up of, copper constantan. Copper constantan. So this is the first pair of materials which make up these two wires. The second pair is chromal aluminal, sorry, not aluminal but aluminal. So chromal aluminal. The third pair is platinum and rhodium. So you can note down these three pairs. So as I told you, these two wires are of different materials. So these pairs, they work out very well for a thermocouple circuit. Now, as we had a quadratic equation for the resistance measurement for the electrical thermometer, that is, the resistance was a function of temperature in that case, and the function was a quadratic function. Alright, similarly, the EMF measurement in this case for a thermocouple would also be a function of temperature, but this would be a cubic function. So EMF is equal to A plus BT plus CT square plus DT cube. So this is a relation that is worth remembering for this topic of thermocouple. Okay, so this wraps up the topic of temperature measurement and zeroth law of thermodynamics. I hope you understood this topic. In the next topic, we start discussing about the heat and the work transfer, and that will lead us on to understanding the first law of thermodynamics. So see you in the next video.